Hi everyone, welcome back to Geospatial Lab. If you are working with satellite imagery and you want to extract meaningful land cover information, you are in the right place. Today, we are doing a full walkthrough of image classification using the Orfeo ToolBox, that's OTB, right inside QGIS. We are going to cover both unsupervised classification and supervised classification. Unsupervised classification using k-means clustering, perfect when you don't have label training data. And supervised classification using a support vector machine, the go-to when you want precise user-defined land cover classes. By the end of this video, you will know how to go from creating color composite all the way to producing a land cover classification, and how to evaluate the accuracy of your results if you have ground truth data. I'll be using a Landsat image of Gatineau region in Quebec, Canada, but the exact same steps apply to any multispectral image, be it Sentinel-2 or Spot. Quick note, before we dive in, make sure you have QGIS installed and OTB configured. So if you don't have the OTB configured, you have to download it and install it. After installation, you need to configure it, and to do that, you come to Plugs in, Manage and Install Plugin. You search for OTB and you make sure you click install. I've already done that, so I don't need to do it again. So after installation, you go to settings, options, processing, providers, you expand this. You also expand OTB, and you make sure that you have the right folder. Your application folder is pointing to where you copied your OTB setup. So then you click OK, and make sure you restart your QGIS. So we start with unsupervised classification, sometimes called clustering. It lets the algorithm find natural groupings in your image data on its own. You don't need to tell it what the land cover classes are. Instead, you tell it how many groups to look for, and it figures out which pixels are most similar to each other. Unsupervised classification is great when you are exploring new area and you don't have training data, or you want a quick first pass at the image. So unsupervised classification involves loading your satellite bands, which I've done here, and you stack them. If you have not done so, I will show you how to stack your bands, that's color composite, and you choose the k-means classification. You set the number of clusters you want, you run your classification, and you interpret the classes. So to start with, I have to stack the bands, that's color composite, and to do that, you go to image manipulation, and you choose concatenate images. You choose the bands, you select the bands, click OK, then you give give the name. So see here, I will just override what I have here already. Click run. So I'll just uncheck what I have here. And this is your color composite, which will be used for the unsupervised classification. To do unsupervised classification, you go to learning, k-means classification. Input the image will be the color composite. The number of classes will be the number of classes we want. For this exercise, I will just choose 3. And you save the image, save to file. I'll give it a name, click save, and hit run. So here is the result. OTB performs clustering using the k-means algorithm, which groups pixels with similar spectral values. K-means gives you statistically distinct groups, but it doesn't know what those groups means in the real world. So that's your job to interpret the results and give the right names. So the algorithm gives you the clusters, you give them meaning. That is, you have to assign names to the classes. To do that, you right-click on your result, go to properties, so you can reassign the referencing system. Then you go to symbology. Under render type, you choose paletted unique values. Click classify and click apply. So you have to give the appropriate color. So for the red, this is water body. So you double click and choose the appropriate color. For the green, that's the vegetation area, which we leave at that. We leave. Then the purple one will be urban area. Click apply. Then you can also give them the proper naming. So blue is what is water, green vegetation, and the orange one will be urban. Click apply, OK, and that is your unsupervised classification, quick and easy. Now let's move to supervised classification, the more precise analyst-driven approach. Here, instead of letting the algorithm figure out the classes, you will teach it. You draw training areas on the image, polygons over locations where you know the land cover type, and the algorithm learns the spectral signature of each class from those samples. Then it applies what it learned to classify the entire image. The steps include loading the satellite band, stacking the band, create training polygons, train the classifier, apply classification model, visualize results, and perform accuracy assessment. So the first process is to stack the band, which I showed earlier when I was doing the unsupervised classification. So I already have the color composite, so I don't need to do that again. So the second step is to create training polygons. And to do that, you have to create a new vector layer. So to do that, you come to layer, create layer, new shapefile, then you give it a name. Geometry type will be polygon. Then you ensure you have the same coordinate system with the image. Create new field. Add the field and then you click OK. So you toggle editing mode. So then you digitize polygon over land cover type that you know. So create polygon. This is for built up area, urban area. ID the one. Then I can say built up or urban. Click OK. So more training samples, the better the accuracy. So I can come here again. Still ID will be 1. Same class, urban. ID 1. Then I do another one for water body. ID 2, water. I can come here again and do another one. 2, water. Then I do for our vegetation area. ID will be 3, vegetation. So let me just do one more for vegetation. Then you make sure you save edit. So the next thing is to train the image classifier. And to do that, you come to learning, train image classifier. Click on that. The input image will be the color composite. You click OK. Then input vector will be the training site. That's a new shapefile we've just created. Then the field are containing the class. That's the ID. The field, that's the ID. Then we choose then the next step is to give the model name. Model, you give it a name. You can use .txt text. Click save, and you hit run. The next step is to apply the classification model, and the tool we'll be using is the image classifier. So still under learning, image classifier, you double click on that. The input image, still the color composite, and the model, you browse to where you save the file. So OTB will not be running the confidence map. That's optional. So you choose, for that, you skip the output. We can skip the output for those. So you give the output the name. That's the result. You give it a name. So we say supervised classification. Click save. Then you hit run. And here you go. You have your result. So you have to assign classes to the result. So you ensure you give appropriate coordinate system. Click apply. Then you go back to symbology, plated unique values, classify. We have 3 classes. So the blue, we leave it as blue. That's a water body. The green, vegetation. And the urban, we can change it to maybe brown or orange. That's fine. And here you go. You have your supervised classification. And so if you have your ground truth, for this exercise, we are not going to do that. So if you have your ground truth data, you can perform accuracy assessments. So to do that, you're still under learning. You go to compute confusion metrics. Compute confusion metrics. So to do that, the input image will be the supervised classification, and the ground truth, that's the vector. Then you input your vector layer here. But for this exercise, we are not going to do that. I'm just showing you if you want to perform accuracy assessment. This is the tool you are going to use, compute confusion metrics. So I'm just going to cancel that because I don't have the ground truth data for this. So, and the overall accuracy is 85%. Anything above 85% is good. And the kappa coefficient between 0.8, 0.6 to 0.8 is also good for the accuracy. And yeah, that is the tutorial for today on how to perform image classification. So in this tutorial, I've showed you how to perform unsupervised and supervised classification. So by now, you should be able to apply both the two methods to your project. So if you found this helpful, don't forget to like the video and subscribe to Geospatial Lab for more GIS and remote sensing tutorials. If you have any questions, drop them in the comments, and I will see you in the next video. Bye.